Okay, so today we're going to be talking about parent functions, and we have a bunch of different parent functions that we're going to talk about. First one is linear. So the linear parent function is y equals x. The table for y equals x, if x is negative 3, y is negative 3. If x is negative 2, y is negative 2. If x is negative 1, y is negative 1. If x is 0, y is 0. If x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. As a graph, we plot those points. Plot those points, connect, draw an arrow. A verbal description of this is that it's a straight line through the origin. The domain of the linear parent function is all real numbers. Okay. So a shortcut to write all real numbers is that it's an R with two lines through it. We could also write that using interval notation. All real numbers using interval notation is negative infinity to positive infinity. And we use parentheses because neither of those are set points. So remember, domain is about your x's, all real numbers, all the negatives, all the positives, all the decimals and fractions in between. The range is the y's, and it's the same thing. All real numbers, or that capital R, or as an interval, negative infinity to positive infinity. The intercepts are where it crosses either the x-axis or the y-axis, or both. In this case, we only have one intercept, and it's 0, 0. Asymptotes are something that we're going to get to later. An asymptote is a barrier to the graph. It's something that the graph gets really close to but never crosses. This graph doesn't have any asymptotes, so we just write none. So linear parent function is y equals x. The graph is a straight line through the origin. Domain is all real numbers. Range is all real numbers. Intercept is 0, 0. No asymptotes. The next parent function is the quadratic. The quadratic parent function is y equals x squared. For our table, negative 3, when x is negative 3, y is 9, then 4, then 1, 0, 1, 4, and 9, because we're just squaring those. When we graph that, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, so when we graph it, it looks like that. That shape is called a parabola. It is a U shape. Has a vertex at 0, 0. For domain, domain is the x's. The x's can be anything, so all reals, or negative infinity to positive infinity. The range, though, is only the positives. So we say that by showing y is greater than or equal to 0. Or, using intervals, it goes from 0 to positive infinity. 0 is going to get a bracket because it's a set point. Infinity gets a parenthesis because it's not. Intercepts are 0, 0, and there are no asymptotes. It's not approaching anything. It's not getting closer and closer to anything. The next one is cubic. The cubic parent function is y equals x cubed. So we're going to cube each of these numbers, and you get negative 8, negative 1, 0, 1, and 8. When we plot those points, you end up with a graph that looks like that. And it's a little bit curved up and curved down. So the right side curves up, left side curves down. Domain is all real numbers. Range is all real numbers. And remember, as an interval, both of those would be negative infinity to positive infinity. The intercept would be 0, 0, and there is no asymptote. Okay, next one is absolute value. Absolute value is y equals absolute value of x. So our table, we'd get 3, 2, 1, 0, 1, 2, 3. Remember, absolute value is the distance from 0, and it's always positive. So when we graph that, you end up with a V shape with a vertex at 0, 0. So it's similar to the parabola, except this one's V-shaped and the other one's U-shaped. Domain is all real. The range is the y's greater than or equal to 0, or 0 to positive infinity. The intercepts are 0, 0, and no asymptotes. The next one is square root. So square root of x. The square root of -2 and -1, those are undefined. We can't do the square root of -2 and -1. So we call them undefined. We can't square root negative numbers. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So I picked 0, 1, 4, and 9 because those are perfect squares, so that they're easy to get the graph, or easy to get the y points for them. So when we plot those, we start with 0, 0, 1, 1, 4, 2, and then 9, 3. So we don't do anything with those undefined ones. So this one starts at 0 and goes on. So you can come up with your own kind of verbal description for that one. Some people in class said it was like a rainbow, or like a shooting star, something like that. The domain can't be the negatives, so we show that as x is greater than or equal to 0, or as an interval, it would be 0 to positive infinity, and that should be a bracket around the 0. The range is the same kind of idea. You can't have a negative here, so it's going to be y is greater than or equal to 0, or 0 to positive infinity. Our intercepts are 0, 0, and there are no asymptotes. Okay, so the reciprocal or rational one is y equals 1 over x. Remember, reciprocal means flip it over. So we're going to take -4, we're going to flip it over, and we get -1/4. Take -2 and flip it over, and you get -1/2. Take -1 and you flip it over, and you get -1. Now these decimals, that -0.5 is like -1/2. So I flip that over, and that's -2. -0.25 is like -1/4. Flip it over, and you get -4. 0 is undefined because we cannot divide by 0. You can't flip 0 over. It's undefined. 0.25 is 1/4, so that's 4. 0.5 is 1/2, so that's 2. And then 1, 1/2, and 1/4. Okay, so when we plot these, we're going to be very careful. We're going to use a scale of 0.5, so this is going to be -1, -2, -3, -4, 1, 2, 3, and 4. Then 1, 2, 3, and 4. -1, -2, -3, and -4. That'll make it easier for us to graph. So when I plot -4, -1/4, it's right there. Then -2, -1/2 is right there. -1, -1. -1/2 and -2. And I just graphed those wrong, so ignore all of that I just said. Negative 4, negative 1/4 would be down here. Negative 2, negative 1/2 would be down here. Negative 1 is there. Negative 1/2, negative 2 would be here. Negative 1/4, negative 4 would be down here. So it curves down like that. So this part of the graph, it's getting closer and closer to the x-axis, and it's getting closer and closer to the y-axis. So that means we're going to have some asymptotes in this one. When I plot the positive side, 0 is undefined, so I don't put anything there. Then I have 1/4 and 4, 1/2 and 2, 1 and 1, 2 1/2, 4 1/4. And there's the positive half of it. So it's two different graphs, two different sections on the same graph. Okay, so domain, the x's can be anything except 0. So I just write x can't be 0. The range can be anything except 0. So I'm going to write y can't be 0. We show that using interval notation like this. The negative section is from negative infinity to 0. Negative infinity gets a parenthesis because it's not a set point. 0 gets a parenthesis because it's not a set point also. The positive half goes from 0 to positive infinity, and both again get parentheses. And we say that those get unioned. We put a U there. That U stands for union. Union just means put it together. So that half put together with that half. There are no intercepts, and there are asymptotes. If we look at this graph, as it moves to the left, it's getting closer and closer to the x-axis. As it moves to the right, it's getting closer and closer to the x-axis. The equation of the x-axis is y equals 0. If we move going up, the graph is getting closer and closer to the y-axis, and if we move down, it's getting closer and closer to the y-axis. The y-axis is x equals 0. So there we have asymptotes. That line is getting really close to the y-axis, getting really close to the x-axis, but it's never touching it. Okay, next one is exponential. The exponential parent function is y equals a to the x. But if we leave it as a to the x, then we can't graph that. We don't have any numbers. So we graph a specific function. We graph y equals 2 to the x. That's going to be our parent function. So 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. So when we plot those points, again, it says use a scale of 0.5. So negative 2, positive 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. When I connect those, you can see that our line is getting really close to that x-axis, but it's not going to touch it. So again, we have an asymptote. So that's where I'm going to start. My asymptote is that x-axis. The equation for the x-axis, though, is y equals 0. That's my asymptote. The intercept here is 0, 1. My range, you'll notice, is all of those positive numbers. So it's y is greater than or equal to 0, or 0 to positive infinity. And 0 gets a bracket this time. Does 0 get a bracket? No. And 0 should just be greater than, y should just be greater than 0. It's not actually equal to it. Remember, I just said it's getting closer and closer to it. So it should just be y is greater than 0. And the interval would be 0 to positive infinity, parentheses on both. The domain, though, that one's easy, and it's all real numbers.